got one more cable I need to attach here. Likes to fall out. Okay, so first off, tell me, Angel, what question did you have from the review? Which one first, anyway?
14.
14?
Yeah.
Okay. Let me write it down before I display it. It's a little bit harder for me to see once I move it over there. Do you have another one in mind after 14?
Yeah, 20.
Okay, I'll go ahead and write them both down for right now. $14 is going to be pretty quick. I just need to remind you of something that I think you'll find it pretty easy once we look at that. Okay, so. There's the review. And let me see if I can. There we go. 14 says find the length of the arc of a circle of radius r intercepted by a central angle theta. What does that say? Round answer to 2 decimal places. Okay. So there is a formula for arc length that only applies when the central angle is given in radians. And it's much easier. I mean, I don't know about much easier. It's simpler than the one for degrees. So let's look at it both ways real quick. Still getting my visual act together here, sorry. Okay, so the formula for arc length in radians is S equals R theta, where S stands for the arc length. I'm honestly not sure why it's S, but there it is. Now this is not in radians because I see a degree symbol. If we wanted to do arc length in degrees, then we think of it as a piece of the circumference. And the size of the piece is indicated by how many degrees we have out of 360. In other words, what part of the circle we have. We say the arc length. We usually don't use S when we're doing that, but we could call that S, is however many degrees we have out of 360 times the circumference. In other words, degrees out of 360 tells me what piece of the circle I have. And so I have that piece of the circumference. So I could do it that way. I could say my arc length, and we'll use S, is 25 out of 360 times 2 times pi times 35. And it said round to the 2 decimal places, so I can go ahead and just put that whole thing in my calculator. And my calculator actually gives me an exact answer anyway, but I need to change that. Sorry, I don't know why it's glitching like that. Change that to a decimal, I get 15.27. Okay, so the other way to do it would be to take this angle and change it to radians, and then it's a simpler formula. Okay, so if we take something in degrees and we want to go to radians, we multiply times pi over 180. So 25 times pi over 180 gives me 25 pi over 180, which I can reduce, but I really don't need to. I could, but I don't really have to here. So once I have it in radians, it's just the radius times the angle, this being the angle. So 25 pi over 180 times the radius. Notice what we're multiplying here versus what we were doing here. You still see the 25, you see the pi, you see the 35 in both equations. The only difference here is this has a 2 and a 360. 2 over 360 is the same as 1 over 180. So you're just multiplying the exact same things. And there's your answer.
What units would that be in?
What would the arc length be in? Inches.
Yeah. Okay.
Whatever the units are of the radius, that's your length, unit of length for the whole circle, for everything related to the circle. So like the area would be in square inches. You good on that one?
Yeah, that makes sense now, thanks.
No problem. Okay, so this one I did not write down everything I needed to, did I? Let's see. It asked me for the sine squared and tells me, let's see. I'm going the wrong way. This is number 20. Find the exact value of the expression if theta is 45 degrees. Do not use a calculator. Okay. So theta is 45 degrees. Oops, that's not what I meant to do. This is, okay. So the sine squared, first we can find the sine, and then if we just square it, we're good. So the sine of 45 degrees, remember this is on the unit circle, that's right in the middle of the first quadrant. And the coordinates there are √2 over 2, √2 over 2, with the y coordinate indicating the sine. So the sine of 45 is √2 over 2. That means the sine squared is that squared. And when you square a fraction, you can just square the top, square the bottom. So this is a 2 on top and a 4 on the bottom, which is 1/2.
Oh, okay, that was easier than I thought. I was really confused.
Yeah, it does kind of look like it's going to be more complicated than that. Let me point out here that this means the same thing as this. Okay. Sometimes people get confused by that because why are we putting the squared on the sine? And the reason is because if you have an angle, like if I write sine pi over 3 squared, it looks like I'm squaring the pi over 3 instead of the whole thing. So you'd have to have the parentheses or like brackets or something. So we tend to write this like this instead, just to say I'm squaring the whole thing.
Okay.
Other questions you want to look at on the review?
Yeah, 21.
Okay.
I just wanted to ask, does the minus just come from the minus pi over 6?
Let's see, I'm sorry.
If you're referring to the unit circle.
Okay, so use even and odd properties. So they want me to use the whole bit about, remember that, I mean, that's one way to do it. It's just to look at negative pi over 6. And instead of going up that far, go down that far. And this is where we're looking at. I'm sorry, you can't see what I'm drawing. This is where negative pi over 6 is. But they didn't want me to do it that way. They wanted me to use the even and odd properties. Okay, and remember that in general, a function is even if when I plug in a negative, I get the same thing as I got when I plugged in the original, anything else. Or the opposite sign gives me the same result. It's odd if plugging in a negative gives me the complete opposite result. Okay, and I'm gonna see if I have it here. Let's see how lucky I get in flipping through these real quick because I had them written out for the notes. But basically out of our 6 trig functions, 4 of them are even and 2 of them are odd. Sine is one that is even, because another way of looking at even and odd, and I don't have them, another way of looking at even and odd is in terms of the visual, the symmetry. Things that are even are symmetric across the y-axis. I don't know how I'm going to draw that. Okay, there's y-axis symmetry. Things that are odd have rotational symmetry around 0, 0, around the origin, like something like that. That if I rotated 180, it would look the same. Okay. So if I take sine values, just to go back through this, let's say I want, let's do a different one. Sine of pi over 4. Okay. That's going to be a positive. Good morning. Okay. If I do sine of negative pi over 4 instead, am I going to get exactly the same thing? In other words, is the y value of this point and the y value of this point, are they going to have the same sign or are they going to have opposite signs is what we're looking at here. Does that make sense? I see a puzzled look. Okay. If I do sine of pi over 4, that gives me a positive. If I do sine of negative pi over 4, I'm going down, so the y value would be negative. Okay, so that matches this right here. When I plug in a negative value, I get the opposite result. That's what just happened there. If I plug in the negative value of the angle, I get the opposite result from the original result. Even, I would get the same result as the original result. So odd, we have sine is odd. That means that cosecant is odd. And that's also true for tan and for cotan. Ways I can look at that is exactly what we did here. If I took the tan of something in this quadrant, it would be positive. If I flip it down to this quadrant, it would be negative. Now, cosine. If I take the cosine of something in the first quadrant, it would be positive because cosine is the x value and I'm going to the right to get to that location. If I flip it down here, I'm still going to the right. So the sign is still the same. Okay, so the cosine of this value and the cosine of this value are the same. So cosine and the one that goes with it, which is secant, are both even functions. So if you give me, if you say whatever function of negative something, if this function is sine, cosine, tangent, or cotangent, then I'll know that my answer is going to be the opposite of what it would be if that negative wasn't there. Because those are all odd functions. If the function you give me is cosine or secant, then my answer is going to be the same as what it would be if that negative was not there. So for instance, wasn't this sine negative pi over 6? I think that's what the problem was. We know then that we're just going to have the negative of whatever the sine of pi over 6 is. That's what this is telling us. So this is kind of like a way that we could figure it out using basically just the positive, just using first quadrant values. So sine of pi over 6 is square root of 3 over, no, it's not, it's 1/2, I'm sorry. So negative 1/2 is my answer. If you ask me the cosine of negative pi over 6, I would say, well, since cosine is an even function, that's going to be exactly the same as just if it was positive. So that's square root of 3 over 2. Okay, so because this is an odd function, you get the opposite result when you change this, the opposite sign. And this is an even function. When you change the angle to its negative, or negate the angle is another way to say that, you get the same thing you would have gotten if you didn't have a negative angle. Let's look. It looked like there was not more. There were more than one problem like that. Use even and odd properties of the trigonometric functions. Da, 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 da. Okay, so the next one is cotangent of negative pi over 3. Let's do tan negative pi over 3 first. Okay, because tan is odd, we know that negating the angle negates the whole result. So in other words, I'm going to have the negative of what I would have had for just a positive pi over 3. To me, every time I think about tan, I go ahead and I think about the coordinates and putting the second one on top of the first one, sine on top of cosine. So that would be the square root of 3 on top. And since these both have 2's in the denominator, that really just is this. So that's negative root 3. Okay, cotan works the same way. So for cotan of negative pi over 3, I'd say I would have to negate or do the negative of cotan of positive pi over 3. And if this is the tangent, then the cotangent is the reciprocal of that, or this. So it's going to be negative this number. Good question. Even and odd is something I don't think I really ever got in high school. I kind of like, or maybe not even know. Honestly, I don't even know if I ever picked it up in college. I never really understood the significance of that. And to be honest, it's because I don't usually think of it that way. I usually just think, oh, go the other way. I don't usually make the connection, and that's just mentally not where my mind goes in terms of making the connection with what would this be if it wasn't negative, and how is that going to change? But if you get used to thinking that way, it can be faster. What else can we do?
Question 40. I just couldn't like visualize what they were trying to say.
Sure, let's look at that. Solve the problem. John, whose line of sight is 6 feet above the horizontal. That's a weird way to put it, but I think what they're telling me there, I don't know what they're telling me. Hang on, let me just keep looking. Line of sight is 6 feet above. Maybe it means, what I think they're trying to say is it starts 6 feet above the horizontal, meaning his eye line, his eyes are 6 feet above 0, but that doesn't, yeah, it's not a weird, it's a weird way to say it. Right, exactly. They could just say he's just 6 feet tall, exactly. Is trying to estimate the height of a tall, I'm gonna have to move it back over here. It's hard for me to read it on the board. Let me 1 second. Okay. I got to move it back to my screen for just a sec. I'll give you back to you. Trying to estimate the height of a tall oak tree, he first measures the angle of elevation from where he's standing as 35 degrees. He walks closer to the tree. Hang on. Sorry, this is the worst tree I've ever drawn. Okay, he walks 30 feet closer to the tree and finds the angle of elevation has increased by 12 degrees. So here we have 35 degrees. When he walks 30 feet closer, this is where he is now. Sorry about the tree. He walks 30 feet closer to the tree and finds that the angle of elevation has increased by 12 degrees. So if I increase 35 by 12 degrees, it's now 47. So this is saying like here, and this is 30 feet. Estimate the height of the tree rounded to the nearest whole number. Okay, so if I find this part here, and I'm sorry that I also drew the tree too tall because this tree is clearly higher than that because the branches go above there. So let's pretend it's down here. When I get this distance, I'm going to have to add 6 feet for John's height. Okay, so I would go ahead and say, let me have this value right here, his distance from the tree after he has moved closer, to be X. And what we have to do here is we have to recognize that if I were trying to find this, and I'm going to call it height, even though I'm going to add 6 feet onto it to get the height. If I'm trying to find that from here, I can set up an equation to find that from here, and same from here, but they're going to have an X in them. But the reality is it's the same height from both places. So, well, we don't really, yes. But in terms of how to set it up, we don't have to find the X first. Like in terms of, it's really how to set it up to get the X. So maybe we're saying the same thing. So in other words, what I'm saying is let's look at just what's happening with the 35-degree angle. 35-degree angle, this is the opposite side. This is the adjacent side. So I can say the tan of 35 equals H over 30 plus X. What that means is that the height of the tree is tan 35 times 30 plus X. Then I can go over here and I can write a similar situation for the 47. I can say the tan of 47 is the height over just the X, which means that the height is tan of 47 times X. Well, we have two different expressions for the height of that tree, and it's the same tree, so the heights have to be the same. So the tan of 35 times 30 plus X has to equal the tan of 47 times X, because those both refer to the height, and the height hasn't changed. Okay, so let's see, how do I want to do this? I'm going to leave it as uncalculated as possible until I get where I want, until I get X alone. You could go ahead and get a decimal approximation for tan of 35, and a decimal approximation for tan of 47. That might make it easier for you. I'm just trying to be as accurate as possible. So I'm keeping everything exact until I get to the part where I can put it in my calculator. So this is tan 47 times X minus tan, let's use parentheses, 35 times X. So I can factor out an X here. It just makes it look yuckier, but I'm doing the exact same thing I would be doing if I made the tan 47 and the tan 35 a decimal. What was the question? I did. Yeah, that's what I was doing right here. Yes. Yeah, because it's something times X and then something times X, so I can factor the X out of both expressions. Good, yeah. I didn't realize how you were asking that, sorry. And now I've got X by itself, and so that tells me that I could put it in my calculator. Tan 35, don't forget to close the parentheses because it's not an angle that's 35 times 30. It's tan 35 times 30 divided by all of that. Tan 47, close parentheses, minus tan 30, close parentheses. I get 42.435, so 42.44. Yes. Nope. What? Oh, I'm sorry. Did I? Hang on. Did I said tan 35 instead of tan 30? I mean, tan 30 instead of tan 35? Let's see. Yeah, I did. Hang on. Never mind. I messed the whole thing up. Let me just type it in again. Okay, I'm getting 56.44. Does that fit what we need? Now, keeping in mind, that's only this part. We have John's height below that. So I'm going to add the 6 and get, what, 62.44? Thank you. I'm dying to finish this problem, apparently. That's the X. That's not the height. You're exactly right. I apologize. That's the X. I was dying to check my answer, so I was jumping ahead. So that's my X. So now I can use either one of these. It doesn't matter which one to find the height. And actually, I would use it written this way. So I'm probably going to use this one. Yeah, it's a little bit simpler. Not hugely, though. I mean, you could do the 30 plus that in your head. So tan 47 times 56.44 gives me 60.52. And that's what I would add the 6 to for the height of the tree. And I'm jumping down to make sure that matches the key. Excuse me. I feel like I'm already getting the seasonal allergy stuff. It's like it's not even that warm. Yeah, they said 67 feet. And I don't know why my screen went away. They said 67 and we got 66.52. And I will wager that if we go back up, it probably says to the nearest foot. And we just did not notice that. It says estimate the height of the tree rounded to the nearest whole number. So there you go. Other questions?
52. That's my last one.
Okay. 52. Find the reference angle for the given angle. So this one is in radians. And the reason I can tell it's in radians is because there's not a degree mark. 52 is basically telling me that this is my angle. Okay. Radians a lot of times have pi. And so it can be disconcerting when it doesn't, when it's just a decimal. But remember in radians, this is how it goes. Okay, pi is about 3.14. 2 pi is about 6.28. Okay, 3 pi over 2, we can go ahead and change to a decimal, but is right in between those. $4.71. So 5.2 is in this quadrant. And if we're asking for the reference angle, the closest value of, or the closest x-axis location is what I tend to think of it as, is right here. So we're looking for how far apart are these two. So I'm just going to subtract 6.28 minus 5.2 because I want it to be positive. Reference angle should always be positive. And my answer is 1.08. Good question. It's really less common to see it like that. And also, good job working all the way through the test review. Looks like you got all the way to the end. That's your last question? Any other things come up?
Yeah, that's it. Thanks, Ms. Backfish.
You're very welcome. I will sit at a Zoom Wednesday morning as well. Don't forget to take the practice test. The practice test can be very helpful.
Yeah, I will. I'll try and take it before Wednesday so I can come with any questions.
That would be awesome. Okay, I'll see you later. Have a great start to your week.
You too. Bye.
Bye.